Okay, so today is just a review day. And so we just are going to go through a couple problems. And quick reminder, I use this binomial distribution calculator that is found right here. So you might want to do that for some of these down here. But that's where I'm getting some of these answers. I'm probably not going to open each one. I'm just going to go through this one quickly since it is review. This is to write the four conditions for a binomial distribution. And these are the four different conditions. Everything must fall into a success or fail. Okay, that's the binomial part of it. There are two answers for each. There's a fixed number of observations. When you go into it, you know exactly how many observations that will be recorded. The number of observations, they all have to be independent of each other, meaning like one has no effect on the other. And the last one is that the probability of success has to be the same for each observation. In number 10, this one's a little bit confusing because this is that 90% chance that it's going to arrive on time. But here we are measuring the probability that you are late, So we're actually going to be, our success for this one, our success is that 10%, which is going to be that we are late. So we have that fixed number of 6. We have the probability that we're going to be late, and they ask specifically in A, what is the probability that you would be late on exactly 2 days? Exactly 2 days. And I got this directly from the binomial distribution calculator. I put in that 6, I put in that 0.1, I put in 2, and boom, I got that 10%. That's a different problem, obviously, but that shows you where I got it from. Okay, so on the next one, it says in B, does it seem like it would be rare to be greater than or equal to 2 days that you would be late? And the answer there is no. Since we already got, for me at least, it was no, because we already got that for 2 days, it would be 10%. 10%. That's not rare. We really deem anything more than 5% is not going to be rare in our class. So 10%, this is saying greater than or equal to 2. So it's obviously going to be even bigger than that 10%. It ends up being 11%, not much bigger, but that's definitely not going to be too rare. To show you how I did this in my calculator, just to remind you, just like yesterday, if I want 2 and above, I get rid of 1 and below. Okay, 1 minus up to 1. So I get that 11%. And my last one, in number 11, it says that we are sowing seeds. It's the same example that we've done before. You have 20 packets of seed. There's an 85% chance that they're germinating. What's the probability that you would get exactly 17 that germinate? Well, that would be 0.24, 24%. You have a pretty good chance of that happening. In B, it says, what's the probability that you would get less than 12? Well, that's going to actually end up being really rare. You should have 17, 18, 19. If you have an 85% chance, having 12, almost half of them, okay, actually more than half of them, right? 12, more than half of them not working when there's an 85% chance, that's going to be very, very rare. So in that one, again, you're just typing in, and these actually go pretty quick. So I'll do this one. 20, I'm putting in the probability is 85% chance. And then from here, I'm going to put in 12. And I want to know less than or equal to 12. I have that, okay, 0.006. When you think of that as a percentage, it's less than a percent. Under 1% of the time. So that is very surprising. I would think for sure something's wrong with that Home Depot batch. And that is all for today.